Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. Hi everyone, and welcome to the HFE Hub. I'm Sharon Todd, and my special guest today is Brian Moon. He is the Chief Technology Officer for Perigean Technologies and the Executive Director of the Naturalistic Decision Making Association. He's a leading practitioner and researcher in the field of naturalistic decision making, also called NDM, and he applies qualitative and quantitative research methods to a wide range of problems, from the elicitation of expert knowledge to the study and design of technology for use in workplace environments. Brian, what a pleasure to have you on the HFE Hub podcast today. And I just wanted to chat with you about yourself and what you do and where you work.
Great. Well, thank you very much for having me. It's great to make connections all over the world in this line of work. So my name is Brian Moon. I am the Chief Technology Officer at Perigean Technologies, which is a company that I founded in 2007 to essentially understand expertise and support expertise through training, software, systems, organizational design. The idea is to really understand upfront what makes for proficient performance. Sometimes we also try to understand what performance looks like across the scales of proficiency, if you will. And so we generally use cognitive task analysis as our approach for understanding expert performance in lots of different domains. I've worked, for instance, in nuclear engineering, healthcare, railroads, pet food, intelligence analysis, and the list goes on and on. But I'm in a community, I think, of folks, much like I'm sure your listeners, who are interested in people at work and trying to help them do their work smarter, better, faster, cheaper, and with a particular focus in our case on the cognitive components of work. And so we, as I said, use cognitive task analysis to sort of reveal the cognitive components of work, whether they're individual components in terms of people trying to make decisions, make sense of the world, manage uncertainty, or whether they're in teams working together and trying to coordinate and find common ground. These are all the things that I'm interested in, and what our company does is help organizations understand that and move from that understanding into applications where we can help them be better at their work.
You talk about performance and cognitive task analysis, and I know that you have a significant interest in naturalistic decision making. What's the connection between the two? Well, maybe the first question should be, what is naturalistic decision making?
Yeah, so it's a mouthful, first of all. It's a very long phrase to essentially describe what it is that people are doing at work. We're trying to get away from this idea of in the real world, but the idea is we're not necessarily interested in, toy problems that college students work on in the lab for pizza money. There's occasionally some interesting findings that come out of going about studying the world that way. But what we are really interested in is going into the environments where people are and seeing them work and talking to them about their work and having them explain what they are going through in their workplace in terms of, again, the decisions that they make, the context in which they make those decisions. So we're particularly interested in domains where the context is characterized by time pressure, organizational constraints, and all sorts of other pressures, which is why many of the domains that I mentioned before are the ones we work in, because those are, of course, characterized that way. So naturalistic decision making is sort of a way to describe a paradigm. It's also a way to think about a community of folks who are interested in this way of understanding experience and expert performance. And then it's a group of people as well. So the NDM community sort of started late 80s and 90s with a group of researchers who, to put it bluntly, were kind of getting fed up with psychology research and cognitive science that was just trying to understand, how people think on these toy tasks and then expecting those to generalize to the real world. And what they found in those days is when they actually went out and talked to people in their workplace and about the work they're actually doing, those models and those theories didn't really align very well. In fact, they didn't really describe the work that people were doing. And when those early researchers kind of went looking for decision making in various domains, they were told by the performers in those domains, we don't really make decisions. And what they were trying to describe and what these cognitive task analysis methods help us to do is people who are highly experienced and proficient in their work, they don't really think of their work as making decisions or trying to optimize decisions, right? They come into a situation, they may have seen it before, in which case they kind of know what to do. Or if they haven't seen it before, they know enough about what's going on and can draw on their past experience to sort of make sense of what's going on. And then either start to plan out an action that, again, maybe they've done before, but if they haven't, they can tweak or mentally simulate through whether it's going to work in this situation and move through that event. So that's a different way of saying we don't make decisions, right? That's just a way of describing how very proficient performers go about their work. And so the early NDM researchers discovered this and built a set of methods in terms of the cognitive task analysis and used those methods to see this sort of thing across lots of different domains. And from the sort of cross-domain look at performance, we're able to develop and continue to refine what we call macrocognitive models of performance. And so this is the things that I mentioned before: planning and replanning, adaptive performance, sense making, and managing uncertainty. So these are the kinds of topics that we're interested in understanding how that plays out in the given domains that we work in.
So really you're talking about how humans handle changing conditions and situations. I imagine.
How they adapt, how they are the resilience in a lot of systems. There's a parallel community of folks, again, lots of overlap with ours, who are interested in resiliency engineering. But again, it's really about, first and foremost, understanding what people are doing in the context in which they work, right? And then trying to not only understand that, but model it in a variety of ways, both qualitative and quantitative. And then from that understanding, start to organize systems, build learning experiences, devise software interfaces, in some cases, also just redesign the entire organization to enable that kind of work to happen. And, a lot of our work actually ends up being about removing parts of systems or removing those hurdles that are getting in the way of experts being able to perform. So a lot of engineering efforts end up sort of creating blocks for proficient performance to happen. We also are very sensitive to enabling folks who don't have as much experience to build that experience through a variety of approaches. We really like simulation-based training and decision games, for instance. And so it sort of depends on what a given organization's trying to do. That will affect how we go about our work. But it generally stems from the same idea. Go out in the real world, see what people are doing, get inside their heads and understand how they're making decisions from their perspective, and then build from there.
So why is it essential to know how people manage changing conditions? And maybe we can talk about the industries where this kind of thinking and research is.
Yeah, it's essential because back to this idea of sort of optimization, right? So a lot of engineering approaches are geared toward trying to optimize systems. But at the end of the day, we know that things go wrong. People make mistakes. Systems are brittle. Unexpected circumstances come up, and the saving grace in many of those cases ends up being people with experience who can adapt to those changing circumstances, not because they know all the answers, but because they have prepared either through experience that they've gained naturally just because they've seen it so many times, or they have processes in place to help them think through what might happen in the future. So things like a pre-mortem method at the beginning of a project to think about not just the benefits that are going to happen when this project goes well, but what might we start to pay attention to realize that this project is not going well, right? So thinking ahead, anticipatory planning, that sort of thing. Those are the approaches that we study, and we try to develop applications that help people to implement these sorts of things, because again, circumstances are going to change. We talk a lot about uncertainty and a little bit about risk, but we're actually much more interested in uncertainty because uncertainty are the things that you don't know about. And so a lot of, again, engineering approaches are going to focus on, managing risk when the risk and the consequences are well defined. We work in domains and with people's experience that is not quite so well defined. And so that's where we're trying to understand, given all that uncertainty, how do people manage it? What do they know to be tracking that other people just aren't paying attention to? What are those subtle cues that they're picking up on that lets them detect problems earlier than anybody else? And so those are the kinds of resiliency capabilities that we try to understand.
You talk about uncertainty. So I'm thinking threat and error, complex real world decision making. And if I'm thinking industry, the first one that comes to mind is probably aviation, or transportation. Are you working directly in that area yourself?
The only aviation projects that I've been involved in is just one where there were no pilots. So we had a project a few years ago with the Office of Naval Research here in the U.S. trying to design and develop the first fully autonomous helicopter that would support Marines out in the field for things like casualty evacuation. The goal of our part of the work was basically to come up with an interface that an 18, 19-year-old Marine could use on a handheld device out in the field to effectively call for casualty evacuation for a full-sized autonomous helicopter where there was no pilot. So lots of uncertainty in that. And we went about that project. I have a couple papers on this that I co-authored with the team to describe our human-centered design approach for, even though we were thinking about autonomous vehicles and what was really an envisioned world, because heretofore this thing had never existed. You always had pilots and crew chiefs and other folks who were part of that operation. Now we were talking about essentially performing that same function, but without any of those people. So the first place we went was to the people who do it these days. And what does it mean to be a pilot in changing circumstances? We're not necessarily interested in learning how to fly helicopters. We're interested in very difficult situations where those highly proficient helicopter pilots have had to perform, because that's what we're going to have to try to design too, right? The most complex situations we can think of. And we did a lot of cognitive task analysis with those pilots, and not just the pilots, but also those units on the ground. Because if you think about it, if you put in an order for a delivery service, all you want is that product. You don't necessarily care how it got to you or what path it was taking. Or now, if it gets delayed, you kind of want to know that. If you move and, you ordered a pizza at your house and now you're going to your friend's house and you'd kind of like the pizza to go over there, you'd want to let the delivery person know that, right? So these are the same sorts of things that you have to think about when you're designing these kinds of capabilities, right? What does it look like when you've ordered a delivery from a helicopter to a landing zone that's no longer there because it's no longer safe, or weather gets in the way? There's all sorts of reasons why those optimal situations are not going to be available to you. So that's the aviation project that I'm really proud to have been a part of. We designed the interface for that mobile device. We met all the requirements in terms of the hardest one, frankly, being this imaginary young Marine has to go from 0 to proficient at this interface in, I think it was 10 minutes. That's all the training that they were going to have on this interface. So it had to be that proficient that someone could just pick it up and realize what it needs, what buttons they need to push and what they need to pay attention to or not in order to complete that mission. So we supported that piece. We also then supported some design on the another part of the problem, which was in an envisioned world, you may have more than one of these flying around in your zone of responsibility, right? So how does this person sitting back at some sort of operations center think about many of these missions going on simultaneously? And so that also introduced a number of design challenges and required us to go see how they do it these days with pilots and, also with autonomous vehicles. But this was a full-size helicopter, which was really the first time anybody thought about what it looks like to have a robotic helicopter flying in those kinds of zones. So really interesting work. Just about aviation, I would say that, yes, there are definitely folks in our community who are interested in aviation. A number of the sort of well-regarded and often used methods, as well as some of the theoretical work, has come out of aviation. And in particular, the military has, the U.S. military in particular, back in the 80s and 90s was funding a lot of this research. And that's where a lot of the cognitive task analysis methods were developed, evaluated, and sort of routinized, if you will, into what they are today.
So what are some of the cognitive task analysis methods?
So it's funny, over the years, there's been a number of attempts to sort of suggest what tools are in the CTA toolbox. There's a number of lists out there. Some of them are very long, and they include everything from a technique that we use quite a bit, which is called the critical decision method. It's an incident-based technique where you're trying to understand a story or an incident from the perspective of the decision maker, which actually has a lot of roots in aviation study as well. We, over the years, have also used concept mapping. I've authored a book on applied concept mapping, which is kind of a diagramming technique for helping people to articulate how concepts relate to each other and sort of propose propositions about the world. So those are two big ones. There've been lots of work over the years actually in trying to create lighter versions, if you will, of cognitive task analysis. There's we call applied cognitive task analysis, but it's a way to get sort of more to the point more quickly than eliciting an entire story, for instance. So you'll hear words like knowledge audit and simulation interviews. But again, the main focus of all of these is to help people. And we know from all of our work with experts in lots of domains that it can be very difficult for people who are really skilled at their job to articulate how they're doing it. Right. And so what we try to do is use these tools to kind of share the burden with them in doing that. So what I mean by that is when you just ask someone to tell you a story about their own experience in this domain and particularly challenging stories at that, they're pretty well able to tell you the story. You've got to sort of structure it for them and keep going back into the story and ask those probing questions that we know kind of get at these cognitive issues that I talked about earlier. So that's kind of, in my mind, sharing the burden. You're not just saying, so tell me how you do your job, right? Yeah, you're saying, can you think of a time when you were really challenged in your job? And then they'll tell you a story or two, and you get the quick version of the story. And then we spend an awful lot of time. These CDM interviews can go 2 hours or more. We spend a lot of time going through the details, and we want to know, what were you looking at that moment? What were you smelling? What were your teammates talking about? Were there, what were you noticing that other people were missing? If someone didn't have this kind of experience, what might they miss? And so those are the kinds of questions you'll hear us ask in the context of that story. So that's again sort of sharing the burden of trying to get this story out, and that's always been my perspective about why these techniques are so valuable, because they allow the interviewer to sort of maintain control, if you will, of the interview, and even if you don't know how the story plays out, you know how this structured interview is going to play out, and so we teach these techniques. I and a couple of colleagues run what's called the CTA Institute. And so the CTA Institute is it's an online learning opportunity for folks to come and understand what CTA is about, get the background on why we do it this way, get some depth in the interviews, the techniques that we use, and not just the interviews though. It's also about analyzing all the data you're going to get. So in these projects, we may talk to a dozen or more people, and so we have analysis techniques to go through that qualitative data and sort of pull out the important pieces, and then also representing that data. What does it mean to kind of model the data and provide it? Because often on projects, we're working in teams ourselves. Sometimes those folks may be software designers, and they're not necessarily human factors folks or cognitive people like us. So we have to convey to them what the designs, what the principles of the design should be, or in some cases, even sketch them out for them, right? What should this look like, and what do we want to avoid? So that's why, the CTA toolbox is pretty wide open, because lots of tools, techniques, and generally folks that practice kind of have their own, pet techniques that they know work well and they go back to. I certainly am a person who relies pretty heavily on both the CDM technique and concept mapping, in particular for representing what we discover in these interviews. Concept mapping is a great way to sort of visualize, here's what we understand the domain to be about, here are the main challenges, here's why this is difficult. And sometimes we code our data by those very categories. So if you're faced with this decision, what kind of cues and factors are you going to be relying on? What are some strategies you use? What are the information sources you rely on? And sometimes more importantly, where do you get those? So a bunch of different techniques for analyzing the data as well. So yeah, that's the start of the CTA toolbox, but it's big, and people put a lot of tools in there. Basically, if you're trying to understand how people do work in the real world, in their proper context, in my mind, you're doing CTA.
This is amazing work, and it's a long way from skill-based and just knowledge-based theories, isn't it? I think I have seen the phrase recognition prime decision model or recognition prime decision making. Is this effectively what NDM is still, or is it morphed into something?
Yeah, it's a great question, and therein lies the common denominator, if you will. So the stories I was telling earlier about people getting fed up with the laboratory studies and going out into the field, that's Gary Klein and the folks who were around him back in the 80s and late 80s or so. You start to see Gary put out the early versions of exactly that, the recognition prime decision model or making, and called it different things at different points. But the overall objective of describing decision making the way that Gary did was to account for this fact that people were saying we don't make decisions. So they weren't laying out this sort of decision strategy or optimizing strategy or multi-attribute approach to analyzing their situations. They were gaining experience and using that experience to find their way through situations and take some sort of action. And that's basically what the RPD model describes. So Gary's own story, and certainly encourage you someday to have him on your podcast as well. Gary's own story is, kind of the start to a lot of what we do in NDM. He was, an originator of the first NDM conference and has been a key figure for us all for the past, many decades at this point. His work has, I think, inspired others to look at decision making, but what else is around decision making, right? So in domains, for instance, where it's kind of sort of difficult to say that there's been a decision point, like, for instance, intelligence analysis, where you're trying to assess something as opposed to make a decision about something. Of course, you make many decisions as you go along, but you're really trying to project and anticipate things, right? So out of thinking about that kind of work has come what we call the data frame sense-making model. And so it's all about how is it that these kinds of folks sort of try to build frames or mental models about the way the world works and test those against the data that they find. And I mentioned earlier also the focus on teams. There's been a lot of folks in our community who have been really interested in how high-performing teams do it and how they work so well together and what it takes to become a high-performing team. And so, there's more to NDM certainly than RPD. RPD has a very special and to some extent exalted place within the NDM framework, as it should. But these other sort of cognitive elements of performance, what we call macro-cognitive, because again, we're not focused necessarily on perception and attention, although we're really interested in attention management. We're not sort of down in that micro level of analysis or measurement. We're more sort of at the macro level of thinking how people get through situations.
How do you manage and this is a huge question because it does depend on the domain where people are working, but we've talked about threats and uncertainty. How do you actually manage error? How do you manage error? Because people are making decisions, but how does your NDM or cognitive task analysis work assist them to determine when they're likely to make an error or where what they're thinking about is probably going to lead them to an error? Do you work in that space is probably the question.
Yeah, we do. And, error is everywhere in every domain. So it's actually, in my mind, not a domain specific question. And the way that I would approach that is to recognize, that we're all fallible. It doesn't matter how much experience you have or how many times you've been around the block. Everyone is susceptible to error. Contrast that, however, with things like, heuristics and biases research, which focuses almost exclusively on trying to recreate errors in artificial ways, and then has a whole list of biases that people are always susceptible to. In some ways, that kind of research is the antithesis of what we try to do in NDM, because again, we're amazed by the things that people are able to do, and we want to continue to help them do those sorts of things with the recognition that systems will fail and uncertainties will overcome us. But we're most interested in how is it that people are able to overcome those things, right? Where we're not just starting with the assumption that people are sort of riddled with these cognitive biases and will never get very far, because that sort of takes you down the path, again, back to this optimizing path, which, folks in artificial intelligence and other related fields are trying to understand what is that optimal way of understanding and making decisions that will reduce error everywhere. Our take on that is people need a lot of diverse experience, and they need to work with really hard problems. They need to see the entire problem as early in their career as possible, right? So what we try to do is offset this lengthy process of developing all that experience by trying to push it as far into, novice domain experience as we can. And so, again, that adaptiveness and the resilience in our mind comes from the experience that people have had. And so we are trying to build that experience so that people have something to draw on in those moments of uncertainty and where things are not going according to plan. So it's kind of a different way of thinking about the problem. Yes, error exists, and we are always trying to reduce error. But, we often find in our work in, areas, domains like healthcare, for instance, where, errors can be life or death. We are trying to reduce error, for instance, by ensuring that people get the data that they need in the ways that they want to receive it, right? And so errors can happen in systems when designers of those systems merge and blend and filter data in ways that were not anticipated by the people who are trying to figure out what's going on. Right. So sometimes error reduction happens by reducing the distance between people with experience and what they're looking for. Right. So there's ways to reduce errors, again, in systems. There's ways to help build people's experience base so that they have something to draw on in moments of uncertainty. And that's what we're after. Again, recognizing fallibility, and nobody's perfect. And we can't possibly know the future anyway. And so we're trying to prepare people for what they might face by giving them a sense of what that looks like.
The software that you develop, is it to guide them through some of their decision making based on the CTA work that you've done with them? Yeah, maybe just explain that to me.
Yeah, when we talk about software in this practice, it's everything from designing interfaces that either enable a process, like, for instance, a clinical decision process, by providing information that might be challenging for someone to gather at the point at which they need it, but also making their access to that data as flexible as possible. So we're not trying to optimize system design to lead someone down some sort of garden path of decision making. We're trying to design systems so that, frankly, so that experienced people can use them, as well as folks who don't have the experience can also get support for their tasks. So sometimes that's what we mean by software. We do work in our community with folks who are trying to develop artificial intelligence systems. Some of the CTA methods actually came out of trying to develop expert systems back in the 80s and 90s as well, with, again, a starting point of understanding how those proficient performers do it. And so sometimes we're trying to work with artificial intelligence developers who may be trying to work toward some sort of optimized system. And frankly, some of our work ends up being more context than they had, right? So they may have some sort of optimal decision approach in mind that they're trying to code, and our work ends up showing where they're going to be brittle, when this system is going to get in the way, and when, frankly, errors are more likely to happen given the system that they have in mind. I mentioned a couple of times worked in the intelligence community. So back in the early 2000s, when there was a heck of a lot of interest in intelligence, and in particular, trying to find the needle in the haystack and all sorts of other metaphors that people would throw in there. I have a paper that I've always been pretty proud of, because it took all those metaphors and looked at the way that information system designers were thinking about those metaphors and then looked at the systems they were building and then showed them why the systems they're building are completely anathema to the way that people need to do work. But you could see it, a pretty clear thread through, the metaphors that politicians would use, the systems developers trying to be responsive to them, and not really understanding, frankly, the cognitive work that had to be done. And you could just see these really glitzy, fancy tools that were getting in the way of the work that the analysts needed to do. So sometimes when we think about transformational systems, we need to be understanding what transformation might look like to the people whose work is going to be imposed on by these systems. So we work in and around software teams because, again, we're either trying to help them better understand what the work's about. Sometimes we do get into usability and sort of down into the details of the system, but generally our best help in these kinds of things is helping those system designers and developers really understand what the cognitive work is. And that means that ideally we are involved in these kinds of projects from the beginning. That doesn't always happen. And so sometimes we get called in after systems have been deployed and nobody's using them, or the systems failed in some way or another. And the issue was they didn't understand the work they were trying to support to begin with.
Greatest problem for all human factors people is getting in at the front end. I completely understand.
Yeah, exactly.
I hear that there's a conference coming up in New Zealand.
Yeah, there is. This NDM community, as I said, has been around for several decades. They've been on a kind of trajectory of every other year conferences. So we've had 16 so far. Most of them, all of them, have either been in the US or in Europe. And there is an increasing interest, I think, in this sort of thing from your neck of the woods. So we wanted to get to that part of the world and hold a conference. So we're going to have the 17th International Conference on NDM is scheduled for July 1st through the 5th at Auckland, at the Auckland University of Technology. My colleague William Wong is there. He previously hosted a conference for us when he was in the UK and is serving as our kind of local co-host for the conference. So we've got 5 days planned. The first day is really going to be about researchers who might be new to this sort of thing, coming and sharing their ideas, their questions with a panel of NDM gurus, if you will, folks who know NDM really well. And so it's an opportunity to see what NDM has to offer for you if you're starting to do, for instance, cognitive task analysis, and it's early in your CTA career, asking, questions about protocols and data analysis. We're going to be there and open for folks to come talk to us about their research and how NDM might be beneficial to them. Day 2, we're going to do a day-long Cognitive Task Analysis Institute. Myself, Gary Klein, and Laura Militello, who's my colleague on the CTA Institute, are going to offer the opportunity for folks to do a one-day, not just instructional event, but coaching as well. CTA is at the end of the day another skill set, right? So you got to understand how to do it, but that's different than getting out there and doing it. So we're hoping we can get some folks interested in the Institute to come learn about it and then train with us, get some feedback, coaching, that sort of thing. So that'll be on day 2. And then the rest of the 3 days, we'll have a combination of keynote speakers. We have 6 scheduled. We'll have about 23 papers in areas like sport, healthcare, AI, and a number of other domains, and then a number of panels as well in those same kind of topics. And then we actually had a conference last year where we introduced a new idea of interactive experiences. So in addition to the standard sort of poster and panel and paper delivery, we have what are essentially mini workshops to show people what some of these tools look like. The CTA workshop will show you what CTA looks like. But as I mentioned, we're very interested in things like scenario-based training and decision games. And that's been an emergent kind of training approach over the past few years. And so we focus our scenarios and simulation decision games on those same stories that we've been capturing from people, right? So the simulations are they're high cognitive fidelity, we like to say, even though they may be paper and pencil, they're going to get at the real world stuff that you're going to face in those situations. So we're able to make pretty complex, build in all those pressures and then have people make decisions and get some feedback on them. So we've got a number of these interactive experiences that will show a number of methods to include decision games. I'm actually kind of excited because we're doing one of these, and traditionally with our decision games, we've been, as I said, using the scenarios and stories that we capture from CTA. We've kind of come up with a technique as well to design a scenario on the fly. So it's kind of a dynamic decision game that we're interested in getting some feedback on as well. So a lot of what folks will hear is both theory and method of NDM, but also new applications in lots of different domains. So it'd be great if folks can join us. Naturalisticdecisionmaking.org is our site. That's where the conference information is. And even if you can't get to Auckland, which I'm hoping folks who listen to this podcast can, but we're also going to stream some of it. And so if you join up either through this conference registration or just with the Naturalistic Decision Making Association, you'll be able to catch the streams. And those will mostly be the papers and the keynotes. And if you are not able to catch the stream live as a member of the NDMA, you will be able to also get the recorded streams later. So we've set up our association, and this was really kind of came about a couple years ago when those folks who were doing that early research back in the 80s and 90s, as they get into the twilight of their career, we want to make sure that this kind of thing endures and that we have a more connected community across the world. So our association is that place.
If you're interested in finding out more about the 17th International Conference on Naturalistic Decision Making, you can find out more information at naturalisticdecisionmaking.org. Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.